Good evening everyone, good evening. I welcome you all again to your Vedantu Enlite channel. I hope all of you are doing great, having a good time. So people, if I'm perfectly audible and visible to everyone, just quickly let me know in the chats. Hello Rifsana, hi Yuvashri, hi Aisha, hello Nandani. Welcome back guys, welcome back. Just quickly let me know in the chats if I'm perfectly audible and visible to everyone. Hello Arya, hello Nandana, hello Hari Prasad, welcome back. I'm doing good guys, I'm doing good, thank you. I'm doing good. Welcome back, welcome back. Just give me a second, I'll fix the things and we'll be starting, right? Just give me a second guys. Just give me a second. Alright, so I welcome you all again to your Vedantu Enlite channel. I hope all of you are doing well. So people, in today's session, what we all think we are going to cover, we'll be discussing the chapter Ionic Equilibrium, right? In this particular session, I've come up with around 30 questions from the chapter Ionic Equilibrium, and I'm sure by solving these 30 questions, your whole chapter is going to get revised properly, and a lot of new things, a lot of basic things will get covered in this particular chapter too, right? So before starting this particular chapter, the ones who have just joined in, the ones who are new to the channel, I'll just quickly introduce myself. So people, my name is Wassim Sir and I'm your chemistry master teacher writer on this Vedantu Enlite channel, yeah? Right? The ones who have not liked the video yet, please do like the video, share the video with your friends, do subscribe to the channel, and do not forget to hit the bell icon so that you get the notification of every single session which we take live on this Vedantu Enlite channel, right? So do like the video, share the video with your friends, and do subscribe to the channel as well. So people, you can quickly let me know in the chats if all of you are super duper excited about this particular session, right? Let me quickly know in the chats if all of you are super duper excited about this particular session. Let me know quickly in the chats fast. Welcome back guys, welcome back. Welcome back, welcome back. Yes Teja, this much is going to be more than sufficient. I'm doing good Ashwa, thank you. Perfect guys, so let's get going. Let's get started with the tonight's session from the chapter Ionic Equilibrium with the first concept which is on the screen, right? This is basically the question which is on your screen, and let's try to solve the question and let's try to get the concept which is involved in this particular question, right? See guys what the question exactly says and how exactly we are going to solve this. Understand and do remember the procedure which I'll be following to solve these sort of questions, right? Okay. Calculate the concentration of each ion at equilibrium for 0.1 molar solution of a weak electrolyte AB. So basically we are starting with the weak electrolyte AB, right? The first thing which I would want you guys to remember, weak electrolyte, it always stays in equilibrium with its ions. That is the first thing which you need to know. Weak electrolyte, it always remains in equilibrium with its ions, and its ions are definitely going to be A positive aqueous and B negative aqueous. And B negative aqueous. Basically, these are two questions which are given to us, right? These are basically two questions which are given to us. Now, first of all, at time t is equal to 0, the concentration of this weak electrolyte, I'm assuming as C molar, and the value of C, the concentration of weak electrolyte at time t is equal to 0 is given to me as 0.1. So the concentration of weak electrolyte initially is given to me as 0.1. Since the reaction has not started, so this is going to be 0, this is going to be 0, right? The simple basic procedure which we follow normally. I'll assume the degree of ionization of this weak electrolyte is alpha. So if I ask you, what is going to be the concentration of each ion at equilibrium? You must say, you are going to treat this concentration in the similar way as you used to treat the moles. So the concentration of AB at equilibrium is simply going to be C minus C alpha, right? That's something which everyone should know. Now, 1 mole of AB gives 1 mole of A positive. So from C alpha, you get C alpha. Similarly, 1 mole of AB gives 1 mole of B negative. From C alpha, you again get C alpha, right? So basically, what did I get? I got the concentration of each ion present in the container at equilibrium, right? Now people, what am I going to do after this? I'll write the expression for ionization constant. And ionization constant, how do we write its expression? If I want to write the expression for ionization constant, it's going to be concentration of A positive at equilibrium raised by stoichiometric coefficient, that's 1. Concentration of B negative at equilibrium raised per stoichiometric coefficient, that's 1. Concentration of AB at equilibrium raised per stoichiometric coefficient, that's again 1. If I ask you, what is the concentration of A positive at equilibrium? You'll say it's going to be C alpha, this term. Concentration of B negative at equilibrium, it's again going to be C alpha, divided by concentration of AB at equilibrium, which is going to be C minus C alpha, right? It's very simple till here, yeah? So people, Ki you will be calculating over here as, it's going to be C square alpha square, right, divided by C minus C alpha. One of the C in the numerator and one of the C in the denominator gets cancelled, so final expression comes out be C alpha square divided by 1 minus alpha. So this is basically the expression for ionization constant first of all, right? This is how you write the ionization constant expression. Now after this, have a look. I need to solve the first part of the question. As for the first part of the question, ionization constant is equal to 10 raised power minus 5, right? Now see how am I going to solve this. I already got the Ki expression, which is C alpha square divided by 1 minus alpha. Now after this point, after writing the expression for Ki, we are going to assume certain things. We'll assume that alpha be less than 0.05. I'm assuming alpha value to be less than 0.05. If alpha is less than 0.05, that means that means instead of 1 minus alpha, I'll be just writing 1. Instead of 1 minus alpha, I'll be just writing 1, right? So my expression of ionization constant becomes simply C alpha square divided by 1. C alpha square divided by 1, right? So from here, you can easily calculate the value of alpha, my dear people, which is going to be under root of Ki divided by C. What about the Ki value? That's given to you as per the question, 10 raised power minus 5. What about the C value? C is the concentration of weak electrolyte, which is 0.1. That means 10 raised power minus 1. So the value comes out be 10 raised power minus 4, which is going to be 10 raised power minus 2 finally, that means 0.01. So this is basically the value of alpha. Now people, you need to check. After getting the value of alpha, you need to check whether this alpha value is actually coming out to be less than 0.05 or not. See, I assumed in the beginning, let alpha be less than 0.05. Now I calculate the value of alpha, right? The value of alpha actually comes out to be less than 0.05. That means whatever assumption you have made over here, that's absolutely correct. That's absolutely correct, right? Now people, after this, after getting the value of alpha, what was I supposed to calculate? I was supposed to calculate the concentration of each ion at equilibrium. So I must say concentration of A positive at equilibrium, that's C alpha. Similarly, concentration of B negative at equilibrium, that's again C alpha. So concentration of both these ions at equilibrium is C times alpha. Now people, what is the value of C basically? C is given to me as per equation, that's 0.1. And what about the value of alpha? That is 0.01. So the value finally comes out to be 10 raised power minus 3 molar. So you got to know exactly the concentration of each ion at equilibrium is nothing, that is just 10 raised power minus 3 molar. So this is how the first part of the question is to be done and dusted, right? Simple and basic. Is it clear till here? Now people, if you look at the second part of the question, see, till here the question remains same. Till here the question remains same. Now we are going to solve the second part of the question. See what the second part of the question says. See what the second part of the question says. As per the second part of the question, ionization constant Ki we need to take as 10 raised power minus 2. The same procedure I'll be following, the same procedure. I'll be again assuming let alpha value is less than 0.05, right? And if I assume that alpha to be less than 0.05, that means instead of 1 minus alpha, you can just write 1. So your Ki value now again becomes C alpha square. And from here, you'll be now calculating the value of alpha, which is going to be under root of Ki by C. Over here, there's one important thing which you need to know. See, Tejas, you'll get your answer now. See guys, Ki value in this particular question now is 10 raised power minus 2. C value is 10 raised power minus 1. Concentration of the weak electrolyte, which comes out to be, this value comes up. So it's going to be under root of 10 raised power minus 1 finally, which is going to be 1 divided by root 10. Root 10 is approximately 3.33, right? And this value will approximately be 0.3, right? This value will be approximately 0.3. See, you got now the value of alpha is 0.3. Now, is this alpha coming out to be less than 0.05? What we assumed in the beginning? We assumed in the beginning as let alpha be less than 0.05. But alpha is not coming out to be less than 0.05. That means whatever assumption you have made over here, that's wrong. You cannot neglect alpha in comparison to 1. So if you cannot neglect alpha in comparison to 1, then what you need to do exactly, see exactly what you'll be doing, my dear people. you'll be writing the Ki whole expression as C alpha square divided by 1 minus alpha. Now you cannot neglect alpha in comparison to 1 because you have checked that, right? You have checked it. You have checked it, right? Now people ask for the question. Ki value is nothing, that's 10 raised per minus 2, right? 10 raised per minus 2. 10 raised per minus 2 means 1 divided by 100. That means 1 divided by 10 raised per 2. C value, concentration of weak electrolyte, given to me as 10 raised per minus 1. 10 raised per minus 1 means 1 by 10, right? And it's going to be alpha square in the numerator. In the denominator, it's 1 minus alpha, right? So first of all, this 1 of the 10 gets cancelled out. So if I solve this properly, it becomes 1 minus alpha is equal to 10 alpha square. So basically, you are getting a quadratic equation over here, which is going to be 10 alpha square plus alpha minus 1 is equal to 0. Since you got the quadratic. So basically, when alpha cannot be neglected, in comparison to 1, at that point of time, you need to solve the quadratic equation, my dear people. And I'm sure you guys know how do we solve the quadratic equation, right? You just need to use the quadratic formula, minus b plus minus root b square minus 4ac by 2a, right? From there, you'll be calculating alpha. And the alpha value you'll be getting, then you can easily calculate the concentration of each ion at equilibrium, which is going to be C multiplied by alpha. Alpha you'll be getting by solving that quadratic, right? C value you know, alpha you can calculate. So C multiplied by alpha gives me the concentration of A positive at equilibrium. Similarly, this C multiplied by alpha gives me the concentration of B negative at equilibrium. That's all, right? Let me know in the chats, my dear people, if it is super clear to everyone. Can you solve these sort of questions from now onwards? This was the general concept which you need to follow to solve these sort of questions. Yeah? Right? They just in NEET examination, they do not, in NEET examination, you need not to solve whether the alpha is less than 0.05 or not. It will be, in NEET examination, it will be always less than 0.05. But in JEE, it cannot be less than 0.05. At that point of time, you need to solve the quadratic, right? Okay, look at this particular question then, guys. Look at this particular question. Just a second. There's a shade coming over here. Just a second. Okay, now it's good. Look at this particular question. See how it's to be solved. The question says calculate the H positive concentration of 0.05 molar CH3COH solution whose Ka value is given to us, right? First of all, we are given with a weak acid. We are given with a weak acid, which is CH3COH, acetic acid, right? Weak acid. Weak acid is the example of the weak electrolyte. And you know, weak electrolyte, it always remains in equilibrium with its ions. And its ions are going to be CH3CO negative aqueous plus H positive aqueous, right? Now we do the same procedure. At time t is equal to 0, its concentration is C. This is going to be 0. This is going to be 0. Now at equilibrium, as you guys know, it is supposed to be C minus C alpha. This will be C alpha and this will be C alpha. If I assume the degree of ionization is alpha, right? Now the dissociation constant, the ionization constant of the weak acid, that's represented by Ka. If you write the expression for Ka, it's going to be same. C alpha square divided by 1 minus alpha. C alpha square divided by 1 minus alpha, right? Perfect. Now you'll be following the same procedure. What procedure? You'll be assuming let alpha key value be less than 0.01. Sorry, less than 0.05. At that point of time, instead of 1 minus alpha, you'll be just writing 1. So your Ka becomes equal to, your Ka now it becomes equal to C alpha square. And from here, you can calculate alpha as under root of Ka divided by C. That's all. And Ka value as per the equation is given to us as 1.25 into 10 raised power minus 6 divided by, what is the C value? C is the concentration of acid, and concentration of acid is given to me as 0.05. 0.05, right? Now you just need to solve it. You just need to solve it, my dear people. Have a look. This is going to be 1. This is going to be how much? This is going to be 25 times. So the value finally comes out to be 5 into 10 raised power minus 3. Look here, my dear people. See, this is the value of alpha which you got. 5 into 10 raised power minus 3. That means this value is exactly equal to 0.005. Check it out. Is the alpha value coming out to be less than 0.05? Absolutely. The value of alpha is coming out to be less than 0.05. That means whatever neglection you have done, that's absolutely correct. Right? That's absolutely correct. Perfect. Now people, what we were supposed to calculate exactly? We were supposed to calculate the H positive concentration at equilibrium. And you guys know the concentration of H positive at equilibrium is nothing. That's equal to C alpha, right? It's equal to C alpha. Since C value, you know, C is the concentration of this weak acid that's given to me as per the equation, 0.05, right? And people, alpha value, you already got, that is 0.005, 0.005. So This is going to be 5 into 10 raised power minus 2, 5 into 10 raised power minus 3. So it's finally going to be 25 into 10 raised power minus 5 molar. So this is the concentration of H positive present in the container at equilibrium. You guys can let me know in the chats if it is super clear to everyone. Fast. Let me know fast, my dear people, if it's super clear to everyone. Yeah? Got to know how to solve these sort of questions easily? All right. Let's move on then to one more. Look at this one. This is one more similar sort of question, but a bit of concept is involved. A small basic concept is involved. Let's see. The question is something like this. Calculate the ionization constant of the weak base. So basically we are starting with a weak base, and your weak base is NH4OH, right? Weak base or weak acid. Both are the examples of the weak electrolytes, and your weak electrolytes, they remain in equilibrium with its ions. And its ions are going to be NH4 positive aqueous plus OH negative aqueous. This is something which you already know, right? Now people, at time t is equal to 0. Initially, its concentration is C. So this is 0, this is 0. Degree of ionization is alpha. So at equilibrium, I'll be left with C minus C alpha, and this is going to be C alpha, and this is going to be C alpha, right? Now as per the question, my dear people, the concentration of OH negative ions in the solution is given. The concentration of OH negative ions in the solution is given as 0.05. And what about the concentration of OH negative, my dear people? The concentration of OH negative at equilibrium, that's C alpha. So basically C alpha value is given to us 0.05, right? So from here, you can easily calculate alpha value, which is going to be 0.05 divided by C. C is the concentration of weak base, and the concentration of weak base is given to me as 0.1, right? So the value comes out to be 0.5. So alpha value is 0.5. Alpha is coming out to be 0.5. So can we neglect alpha in comparison to 1? No way, you're not going to do that, right? Because alpha value is not coming out to be less than 0.05. Yeah? So you are not going to neglect alpha in comparison to 1. So you just are going to write the expression for Ki, which is normally going to be C alpha squared divided by 1 minus alpha. And C value, you know that 0.1. Alpha value 0.5. So it's 0.5 ka square. 1 minus alpha, 1 minus 0.5 comes out to be 0.5, 1 0.5, 1 0.5 cancel. So final value comes out to be 0.05 exactly. So this is exactly the value of Ki which you were supposed to calculate as per the question. You guys can let me know quickly in the chats if it is super clear to everyone. Fast. Let me know quickly, my dear people, in the chats if it is clear to everyone. Exactly. Perfect, guys. Now, look at this question. Calculate the concentration of each species at equilibrium in an aqueous solution containing. See, the first question you can do on your own. The first question you can do on your own. I'm not going to solve this. Let me show you the second question. Let me show you the second question in which common ion effect is used. See, guys, I'll just show you the second question. The first one you guys are going to do on your own, right? See exactly what I'm going to do. As for the question, we have got NH4OH in the container. NH4OH, which is a weak base. So it's going to remain in equilibrium with its ions, and its ions are absolutely going to be NH4 positive aqueous plus OH negative aqueous, right? This is your weak base which is present in the container. Now at time t is equal to 0 initially, let's say its concentration is C. This absolutely 0, this one is 0. Let's assume the degree of ionization is alpha. So I must say at equilibrium, I'll be left with C minus C alpha, and this is going to be C alpha, this is going to be C alpha, right? So basically we have got a container in which NH4OH is in equilibrium with its ions. Now in the same container, my dear people, in the same container, you are introducing NH4Cl as well. Well, NH4Cl, it's a strong electrolyte. If it is a strong electrolyte, it's going to dissociate completely into its ions, and its ions are going to be NH4 positive plus Cl negative, right? Let's say its concentration is C1, and concentration of this NH4Cl is given to me as 0.1. So initially this was 0, this was 0. Now it's a strong electrolyte, it would have got dissociated completely into its ions, so I'll be left with 0. This is going to be 1 mole gives 1 mole, from 0.1 you get 0.1, even this is 0.1. Or let me not write it in the form of 0.1, let me write it in the form of C1. See, 1 mole gives 1 mole, from C1, you'll be getting C1, this is C1. Now basically in the same container, you have got two electrolytes. A weak electrolyte and a strong electrolyte, and both having one ion in common, that's NH4 positive, right? Both having one ion in common, which is NH4 positive. If I ask you what is going to be the total concentration of NH4 positive, it's going to be C alpha plus C1. This is the total net concentration of NH4 positive in the container. Now people, since you have got a weak electrolyte and a strong electrolyte, both having one ion in common, right? So a common ion effect is going to operate over here. And due to common ion effect, the first reaction, it will shift backwards. It will shift backwards. Due to which the degree of ionization will further reduce. Right? The first reaction, it will shift backward due to the common ion effect. Right? And if the first reaction shifts backward, I'll say its degree of ionization will decrease. Right? Right, people? So whenever you want to neglect alpha, you can do that. Right? If you want to neglect alpha now, you can do that easily. So instead of C1 plus C alpha, you'll be just writing C1. So you have neglected this whole term. Now guys, have a look. Now what I'll be doing, I'll be now writing the dissociation constant of the weak base expression. It's going to be equal to concentration of NH4 positive at equilibrium, that is just C1. Concentration of OH negative at equilibrium, that is C alpha. Divided by concentration of NH4 OH at equilibrium, that's C minus C alpha. I'll take C common, 1 minus alpha, right? So C and C got cancelled out. So Kb value is equal to C1 multiplied by alpha. And as I told you, I can neglect alpha wherever I want. So instead of 1 minus alpha, you can just write 1. So what you are supposed to calculate? I'll calculate alpha from here. It's going to be Kb divided by C1. What is Kb? Dissociation constant of the weak base. That's 1.8 into 10 raised power minus 5. Divided by C1. What is C1? C1 is the concentration of the strong electrolyte. That's 0.1. Right? 0.1 means 10 raised power minus 1. So the value comes out to be 1.8 into 10 raised to the power minus 4. So this is the value of alpha. Since you got the value of alpha and you were supposed to calculate the concentration of each ion at equilibrium. See, the concentration of NH4 positive is just C1. And C1 you know, that is 0.1. So its concentration is already 0.1 molar. Now I must say the concentration of OH negative at equilibrium is equal to C alpha. And C value you know. Do you know the C value? Well, C is the concentration of NH4OH. C is the concentration of NH4OH. Yes, concentration of NH4OH is given to us as 0.1, right? Multiplied by alpha value, you already calculated, which is 1.8 into 10 raised to the power minus 4. The value comes out to be 1.8 into 10 raised to the power minus 5 molar. So this is basically the concentration of OH negative present in the container at equilibrium, which we were supposed to calculate. Just let me quickly know in the charts if it is again clear to you. Fast. Right, people? Clear to everyone? Wonderful. So let's move on to one more. Calculate the concentration of H positive and CH3CO negative at equilibrium is 0.5 molar HCl is added in an aqueous solution containing 0.1 molar CH3COH. Given Ka for acetic acid is 1.8. Again, you are going to solve the equation by following the same concept, that's common ion effect, right? You're going to use the common ion effect and try to solve the equation in a similar way, the way I solved the earlier equation. The equation is based on the same thing. So you have got a weak acid, which will be present in equilibrium with its ions, right? And then you have got a strong acid, HCl, in the same container. So common ion effect will operate, right? So alpha, you will have to neglect, right? So finally, you'll be getting Ka is equal to, you'll be getting alpha as Ka divided by C1. Ka divided by C1. C1 is the concentration of strong acid, right? So from once you get alpha, then you can easily calculate the concentration of each ion. Well, the concentration of common ion H positive is just going to be C1, right? C1 value, you know. C1 is the concentration of strong electrolyte, 0.5. So the first question is done. Concentration of H positive, that means common ion is 0.5 molar. And concentration of CH3CO negative is going to be C alpha, 0.1 multiplied by alpha, which you would have calculated. I mean, you just need to solve the question in the same way as I solved the earlier question, right? The procedure is just same, right? Okay, now let's have a look. Calculate the pH of the following. Questions based on pH. These sort of questions are asked. Let's have a look exactly how do we solve them. See guys, we need to get the pH of the following. First of all, you are given with 10 raised power minus 7 molar HCl, right? HCl is a strong electrolyte. It will be getting converted into H positive aqueous plus Cl negative aqueous, right? So basically, you are putting this HCl into water, and this HCl into water is getting ionized as H positive plus Cl negative, right? See, at time t is equal to 0, its concentration is 10 raised power minus 7 molar. This is going to be 0, this is going to be 0. Now it's a strong electrolyte, it would have got completely dissociated, so I'll be left with nothing. 1 mole gives 1 mole, from 10 raised power minus 7, you get 10 raised power minus 7. This is 10 raised power minus 7. So basically, you got to know exactly in the container what is the H positive concentration. In the container, the H positive concentration is just 10 raised power minus 7 molar, right? So if you calculate pH, pH stands for minus log of H positive concentration. That's 10 raised power minus 7. The value comes out to be 7. So is 7 going to be the pH of the resulting solution? The 7 is not going to be the pH of the resulting solution, because if 7 was the pH of the resulting solution, the solution was supposed to be neutral, but it's an acid. Its pH is supposed to be less than 7, right? So how we are going to solve this? Have a look. Have a look, guys. This is basically the concentration. This is the concentration of H positive, which you are getting from the acid. Basically what you did, you had put this acid into water, and water, you know, that's already a weak electrolyte, which will be already present in equilibrium with its ions, right? Right, people? Again, listen to me. See, you're putting HCl into water. Water itself is a weak electrolyte, which is already going to be in equilibrium with its ions. So in the container, there was already water present. There was already H positive ions present, and concentration of H positive in the pure water at 25 degrees centigrade, that's 10 raised power minus 7 molar. So basically, already in the container, due to water, the concentration of H positive was 10 raised power minus 7 molar. Now after addition of this acid, right, the new H positives again are going to come as 10 raised power minus 7. So what is going to be the net H positive concentration in the container? It's going to be 2 into 10 raised power minus 7, as simple as that. This is the net H positive concentration in the container. So people, if you got the net H positive concentration, you can calculate pH, which stands for minus log of net H positive concentration. Minus log of this term, right? And when you solve this minus, you will keep as such. Log of m in 10 is going to be log of m plus log of n, right? Which is going to be equal to minus times. Log 2 is nothing, that's 0.3. Log of m raised power n, that's n log m, so it's minus 7. So the value comes out to be 6.7. So 6.7 is basically the pH of the resulting solution, which you were supposed to calculate. Can you solve these questions from now onwards? Yeah? Isn't it simple, guys? Look at the second part of the question, my dear people. Look at the second part of the question. See. See, guys. You have got basically NaOH with a strong base, so it is going to get completely converted into its ions, and its ions are Na positive aqueous plus OH negative aqueous, right? At time t is equal to 0 initially, the concentration of NaOH is given to me as 10 raised power minus 8 molar. So this is 0, right? Since it's a strong base, so it's a strong electrolyte, it would get completely dissociated into its ions, right? And its ions are simply, I mean the concentration of NaOH left is going to be 0. 1 mole gives 1 mole from 10 raised power minus 8, you get 10 raised power minus 8. 1 mole gives 1 mole from 10 raised power minus 8, you get 10 raised power minus 8. So basically you're putting this NaOH into water, my dear people, and in the water there'll be already OH negative ions present, and at 25 degrees centigrade in pure water, what is the concentration of OH negatives? That's 10 raised power minus 7, right? Now when you add this NaOH into the same water, right, what is going to be then the total OH negative ion concentration? Already there were 10 raised power minus 7 molar OH negatives in the container, right? Now there'll be 10 raised power minus 8 more OH negatives in the container, right? Now people, if you just take 10 raised power minus 8 as common, right, this is going to be 11 into 10 raised power 8. If you just take 10 raised power minus 8 as common, right, it's coming out to be 11 into 10 raised power minus 8. Perfect. Since you got the OH negative ion concentration, now I'll be calculating POH, which stands for minus log of net OH negative. Net OH negative is 11 into 10 raised power minus 8, right? Log of 11 is 1.05. So it's going to be equal minus times. It's going to be log of m into n, so log of 11 plus log of 10 raised power minus 8. I'm sure it's clear till here, right? Now we will have a look exactly. Have a look exactly what I'm going to do. So I'm going to write POH. POH is going to be equal to minus times. Log of 11 is 1.05. Log of m raised power n log m, so it's going to be minus 8, right? So it's going to be how much? It's going to be, I believe, this is going to become as minus 1.05 plus 8. How much it will be? It will be 6.95, right? This is the POH which you calculated. But where you suppose calculate POH or pH, you were supposed to calculate pH. You know, at 25 degrees centigrade, pH plus POH, that's always equal to 14. So from here, you can easily calculate pH, which is 14 minus POH. So 14 minus 6.95, the value comes out to be 7.05. So this is the actual pH of the solution which you were supposed to calculate, right? Perfect, guys. Let me know in the chats if it's clear to everyone, then only I can show you for more variety of questions. Let me know in the chats if it is super clear to everyone first. Yeah? Usually you're not supposed to remember all the log values. Some common log values you are going to remember, that's all. Some common, not all. right? There is no fun of remembering all the log values. Surely, I'll be doing that in near future. Okay, look at this particular question, guys. This is one more question. Let's have a look exactly how this sort of a question is to be solved. See what the question says exactly. Calculate the pH of the following mixture. So basically, you have got H2SO4, right? And you have got HCl. You have got HCl. First of all, H2SO4, it would have got dissociated completely as 2 times H positive aqueous plus SO4 dinegative aqueous, right? And this HCl, it would have got dissociated as H positive aqueous plus Cl negative aqueous, right? H positive aqueous plus Cl negative aqueous, right? Now people, basically, you are introducing both the acids into the same container. You are putting both the acids into the same container. And finally, the mixture which we get, after mixing both these acids together, the mixture you will be getting, you need to calculate its pH. You need to calculate the pH of the mixture, which you will obtain on mixing these two acids. Simple. See guys, first of all, at time t is equal to 0, have a look. Molarity of this solution is given, its volume is given. So if I multiply molarity with its volume of solution in ml, I'll be getting the number of millimoles of H2SO4. So 0.5 multiplied by 200 comes out to be, multiplied by 400 comes out to be 200. So basically, initially, in the container, there will be 200 millimoles of H2SO4. So this is going to be 0, this is going to be 0. Do remember? Molarity multiplied by, molarity of the solution multiplied by volume of solution in ml. It gives us the number of millimoles of solute. In the similar way, if I ask you how many millimoles of HCl are in the container initially, 400 multiplied by 0.5. So again 200 millimoles. So this is 0, right? Now both the acids are strong acids. They would have got dissociated completely into their ions. So I'll be left with nothing. 1 mole gives 2 moles. So 200 will give 400. This is going to be 200. This will be 0. This will be 200. This will be 200, right? If I ask you how many total millimoles of H positive will be there in the container? How many total millimoles of H positive will be there in the container? You'll say 400 plus 200 comes out to be 600. So these are the total millimoles of H positive present in the container. As simple as that. Well, if you got the total millimoles of H positive, you can calculate the net H positive ion concentration, which is going to be equal to millimoles of H positive divided by total volume. Total volume is 400 plus 400, 800, right? So the value comes out to be 3 divided by 4. So this is basically the concentration, the total H positive ion concentration in the container. Since you got the net H positive ion concentration in the container, you can clearly calculate the pH. And pH is nothing that's going to be equal to minus log of H positive concentration, which is 3 by 4 you calculate, right? So minus you're writing as such log of M by N, which is log of M minus log of N. That's all, right? So log of 3 is nothing, that's 0.47. Log of 4 is 0.6. When you solve this, the value comes out to be 0.13. So this is the resulting pH of the solution, which you were supposed to calculate. You guys can let me know in the chats if it is clear to everyone fast. Is it clear to everyone, people? Let me know fast in the chats if it is super clear to everyone. That's great, Vishnu. Good to hear that. Okay, moving on to one more, guys. This is the similar sort of question which you are going to solve in the similar way. The way I solved the question, right? You are going to solve this question in the similar way, right? Right, people? So pH is given, you can calculate the concentration of H positive, which is 10 raised by minus pH. Then you can just use the mixing technique, which I shown you a few minutes back, right? And get the pH. And this is the final solution, which you'll be getting in the PDF, right? If you could not, for example, solve the question, then you can go through the solution as well, right? Perfect. The simple and basic question, you are going to solve it in the similar way as we solved the earlier question. Moving on to one more. This is one more question, my dear people. This is again the similar question. You have got a strong acid and weak acid in the same container, so you are going to use the common ion effect, right? And as per the common ion effect, the concentration of H positive, the concentration of common ion in both the acids is going to be H positive. Do remember, the concentration of common ion is always decided by the strong electrolyte. And strong electrolyte is HCl. So the concentration of H positive is nothing, that's 0.1. This is the net H positive concentration, 0.1, right? So you need to calculate pH. pH is going to be equal to minus log of this value, that's going to be 1. That's all, right? That's all. Do remember, the concentration of the common ion, that's completely decided by the strong electrolyte, right? Since the strong electrolyte dissociates with the stoichiometry as 1:1:1, right? HCl dissociates as H positive plus Cl negative. So the concentration of HCl is going to be same as the concentration of H positive, which comes out to be from this particular acid, right? Okay, which is always equal the total H positive ion concentration. Just remember, the common ion concentration is entirely decided by the strong electrolyte, that's all. So from there, I calculate the concentration of common ion, which is H positive, then pH is going to be 1, that's it. Or you can follow the lengthier method as well, which I've shown you a few minutes back. If you remember common ion effect question I showed you, right? Okay, calculate the hydrolysis constant and degree of hydrolysis for NH4Cl. First of all, if you talk about NH4Cl, it is a salt, right? NH4Cl. It contains two ions, NH4 positive, Cl negative. Can I say NH4 positive would have come from NH4OH and Cl negative would have come from HCl, right? This NH4OH is a strong base, it's a weak base, right? And HCl is a strong acid. So basically, this is a salt of weak base and strong acid, right? So basically, this is a salt of weak base and strong acid. Yeah, and you know, when the salt of weak base and strong acid undergoes hydrolysis, how do we calculate the different parameters? See, first of all, if I talk about the hydrolysis constant for the salt of weak base and strong acid which undergoes hydrolysis. So hydrolysis constant, it's equal to what? It's equal to Kw, which is the ionic product of water, divided by Kb, which is the dissociation constant of the weak base, right? Similarly, if you talk about the degree of hydrolysis H, it's going to be equal to under root of Kw divided by Kb multiplied by concentration of the salt, C, right? Similarly, if you want to calculate pH, pH is going to be 7 minus half of, it's going to be P of Kb plus log of C, where log C, where C is the concentration of salt. Guys, you just need to remember these formulas and put these values in the formula. See, at 25 degrees centigrade, Kw is 10 raised per minus 14. Kb value given to you as the equation. From here, you will be calculating the hydrolysis constant, right? Kw 10 raised per minus 15. Kb, you know, 1.8 into 10 raised per minus 5. C is the concentration of salt, and concentration of salt is 0.1. So you can calculate H, right? Similarly, all these parameters are given. You can calculate easily the pH of the resulting solution as well. I'm sure you can solve it, right? This is the way you are going to solve them. This is one more similar sort of question, right? Similar sort of question, just the formula based, right? Just the formula based. So you were given with the number of moles of the salt and the volume of solution. So first of all, you calculate the concentration of the salt. And then you identified the salt is of weak acid and strong base, right? If the salt of weak acid and strong base undergoes hydrolysis, then how do we calculate KH? Kw divided by Ka. This is the formula. Kw at 25 is 10 raised per minus 14. Ka value is given. Similarly, H you can calculate Kw divided by Ka into C. All the parameters are given. This is the pH formula. All the parameters are given. You can use these parameters and get the answer. That's all, right? Okay, look at this question, guys. Look at this question. The question is of acid-base titration. See, as per this question is concerned, we are mixing acid with a base. So basically, you are mixing CH3COH with NaOH. And you know, when acid reacts with base, you will be getting the salt. And with the salt, you will be getting water as well. The first thing which I'll be doing, I'll be calculating the millimoles of both the reactants. CH3COH, its molarity and volume is given to me. So multiply its molarity with volumes, you'll be getting the millimoles as 10. Similarly, what about the millimoles of NaOH? This multiplied by this, the value comes out to be 10. So this is going to be 0, this is going to be 0. Since the reaction is already in balanced form. Now people, you'll be using the concept of limiting reagent over here. Which one is the limiting reagent among the two? Check it out. Given millimoles by their respective stoichiometric coefficients. 10 by 1 is 10, 10 by 1 is 10. The value comes out to be same. So this is the case of complete neutralization, right? So I'll be left with nothing over here. Finally. So 1 mole gives 1 mole. So from 10 millimoles, you'll be getting 10. And there'll be 10 millimoles of water in the container as well, right? So you got to know, at the end, you'll be having 10 millimoles of the salt and 10 millimoles of water in the container. Now, if there is only the salt and water in the container, will this salt undergo hydrolysis? Absolutely, this salt will undergo hydrolysis. And this is the salt of, my dear people, weak acid and strong base. This is the salt of weak acid and strong base. And how do we calculate the salt of weak acid and strong base hydrolysis? pH. How do we calculate the pH of the salt of weak acid and strong base when undergoing hydrolysis? Right? Isn't it going to be 7 plus half of, now what I'm going to write over here, it's going to be P of Ka, and then it's going to be plus log of C, where C is the concentration of salt. Now you just need to put the parameters, 7 plus half of P of Ka. K value is given to us. P stands for minus log. Do remember minus log of this value is always 4.74 plus log of C. C is the concentration of salt. What is the concentration of salt? Since you know the millimoles of salt, just divide the millimoles of salt by the total volume of the system, which is 100 plus 100, 200. So this gives you the concentration of salt, and concentration of salt comes out to be 10 divided by 200. That means 1 by 20, right? Just you need to solve this equation, get the pH of the resulting solution. That's all you were supposed to do, right? Right, people? So let me show you the final answer of this particular equation. See, after putting all the parameters over here, you're getting the final pH of the solution is 8.72, right? Let me know in the chats quickly if it is clear to everyone, then only I can show you one more similar sort of question so that this concept gets clear to you properly. Till then I can have some water. First. Perfect, guys? Okay, let's move on. This is one more question, the similar sort of question, but see, I just have changed certain values in the question, and due to the change in the values, the whole question would have got changed. And how come? Let's have a look. See, guys, basically as per the question, you're making CH3COH. You're making CH3COH to react with NaOH. And when acid reacts with a base, it leads to the formation of salt. And with the salt, you'll be writing water as well, right? The first thing which I'll be doing, I'll be calculating the millimoles of the acid. And what about the millimoles of the acid? Molarity multiplied by volume, so 10. So you have got 10 millimoles of it. How many millimoles of NaOH you have? Molarity multiplied by volume in ml, 5 millimoles. So this is 0, this is 0, right? So which one is the limiting region among the two? NaOH is the limiting region, I'll be left with nothing. Out of 10 millimoles, 5 millimoles have reacted, so I'll be left with 5 millimoles of CH3COH at the end. Now, 1 mole gives 1 mole. From 5 millimoles, you'll be getting 5 millimoles, and you'll be getting 5 millimoles of this one as well. So finally, in the container, you're left with 5 millimoles of acid. You're left with 5 millimoles of the salt. You're left with 5 millimoles of water as well, right? Now, people, in the container, finally, you are left with weak acid, and this is basically the salt of the same weak acid with a strong base, right? Weak acid and the salt of weak acid with a strong base. Weak acid and the salt of weak acid with a strong base, right? So basically, finally in the container I'm getting acidic buffer. And how do we calculate pH of the acidic buffer? It's P of K plus log of concentration of conjugate base, or I'll be writing over here as concentration of salt divided by concentration of acid, right? Now guys, P of Ka value, P of K, P stands for minus log, and minus log of this value already I've told you that's 4.74 plus log of concentration of salt. What is the concentration of salt? Millimoles of salt divided by total volume. Total volume is 100 plus 50, 150, right? Millimoles, 5 divided by 150, whole divided by concentration of acid. Concentration of acid is going to be millimoles of acid divided by total volume, that's 150. So this whole term becomes 1, log of 1 is 0. So resulting pH of the solution comes out to be 4.74. So 4.74 is basically going to be the pH of the resulting solution, right? I'm sure this should be clear to everyone, right? Perfect, guys. So that's how the question was to be solved, and the final pH of the solution is coming out to be 4.74. Similar type of question which you guys are going to do on your own, right? It is just I'll change certain values. Okay, Ksp for MgOH whole twice. A very simple and basic question. This 10 raised per minus 14, okay? See guys, if you talk about MgOH whole twice, right? It would have got dissociated as Mg di positive aqueous plus 2 times OH negative aqueous, right? Let's say its solubility is S, so this is going to be S, even this is going to be 2S, right? Now if I write the Ksp expression is simple. It's going to be concentration of Mg di positive raised by stoichiometric coefficient 1, concentration of OH negative raised by stoichiometric coefficient 2. So this value is basically S, OH negative, it's 2S raised to the power 2. It's going to be 4S cube, correct? Well, the Ksp is given to me. Ksp value is given to me. How much? 3.2. Or let me write it like this. Ksp value you got to know as 4S cube. So from here, you can easily calculate S value. I'll say S is nothing. That's going to be Ksp divided by 4 whole raised to the power 1 by 3, right? So Ksp is nothing. That is basically 3.2 into 10 raised to the power minus 14. right? Divided by 4, whole raised power 1 by 3. So it's going to be 0.8 into 10 raised power minus 14, or you can write 8 into 10 raised power minus 15 raised to the power 1 by 3. The value comes out to be 2 into 10 raised power minus 5 molar. This is the solubility in water which you were supposed to calculate. That's all, right? Isn't it simple, my dear people? Isn't it simple? Let's look at the last question of the tonight's session, right? And these sort of questions are asked, by the way, these sort of questions are asked. Let's see how this is to be solved. Let's see, guys. Ksp of Ag2CO3 is given. So Ksp of Ag2CO3 is given. So first of all, Ag2CO3 would have got dissociated as 2 times Ag positive aqueous plus CO3 dinegative aqueous, right? Let's say its solubility is S. This is going to be 2S and this is going to be S, right? Perfect. Ksp is also given. Now people, you are given with AgNO3 as well. You are introducing AgNO3 in the same container, which would have got dissociated completely as Ag positive plus NO3 negative. The concentration of AgNO3 is given to me as 0.1 molar. So initially this is 0, this is 0. Now finally this is 0, this is 0.1 and this is 0.1. So basically in the same container we have the weak electrolyte and the strong electrolyte, and both having one ion in common, right? So what is the total common ion concentration? Isn't it going to be 2S plus 0.1? Absolutely. And due to the common ion effect, what is going to happen to the solubility of Ag2CO3? It will decrease because the reaction favors in the backward direction. So due to that, it will be only 0.1 now, right? Now write the Ksp expression again. Ksp you are going to write as concentration of Ag positive, raised power 2. Concentration of CO3 dinegative, raised power stoichiometric coefficient, that's 1, right? Now people, Ksp value is given to me as per the question, which is 8 into 10 raised to the power minus 12. Ag positive concentration, that's 0.1. 10 raised power minus 1, raised power 2, so 10 raised power minus 2. CO3 dinegative concentration, that's S. And S value is something which I was supposed to calculate. So 10 raised power minus 2, 10 raised power minus 2 cancel. So S comes out to be 8 into 10 raised power minus 10 molar. That's something which I was supposed to calculate as per the question, I believe, right? The molar solubility of Ag2CO3, right? Which came out to be 8 into 10 raised power minus 10, right? So that is the final answer of the question. So people, I'm sure this session would have definitely helped you out in order to tackle certain concepts from the chapter Ionic Equilibrium, right? Okay, and with this, your chapter would have got revised properly. I'm sure about that as well. And if you're not enrolled into the JEE crash course yet, do get enrolled as soon as possible. The batch started yesterday only, right? It is completely affordable. Your whole syllabus of physics, chemistry, and mathematics is done and dusted in this particular batch. And this batch is starting in English as well as English language, right? Your whole syllabus, your test series, every single thing is included in this particular batch. Do get enrolled as soon as possible, right? Super 100 for NEET 2022. I'll let you know about that soon, okay? And if you've not liked the video yet, my dear people, do like the video, share the video with friends, and do subscribe to the channel. And the link for the enrollment towards this batch is there in the description box of the video. So with this, I'll be taking a leave here. Take care. Do let me know in the comment section if you liked the video or not, right? Take care. God bless you all. Bye.